Welcome to our lecture on join queries in relational databases. Today, we'll explore various aspects of SQL joins, which are crucial for combining data from multiple tables effectively. Our outline for today includes understanding the basics of join queries, where we'll differentiate between left and right tables. We'll then dive into using aliases and prefixes to make our SQL queries more readable. We'll construct different types of joins like inner, full, left, and right, and explain how to implement equijoins and non-equijoins. Let's start with the basics of join queries. Joins are essential for merging data from two tables based on a common attribute. In this example, we see how to match the manager from the department table with the employee ID from the employee table. Next, we discuss prefixes and aliases. These are used in SQL to distinguish between columns with the same name in different tables or to simplify column names in our result sets. Now, let's look at types of joins. There are inner joins, which only include matching rows from both tables, and full joins, which include all rows from both tables, using null for unmatched entries. Here's an example of an inner join where we match faculty with their departments based on a department code. The full join example demonstrates how all faculty and departments are listed, even if some don't match, resulting in null values for those entries. Moving to left and right joins. These are used when you want to see all records from one table, matched or unmatched. In this example, a left join would show all departments even if they don't have a corresponding manager. Let's explore equijoins versus non-equijoins. Equijoins compare columns with an equality operator, while non-equijoins use other comparative operators. Here's a non-equijoin example where we're joining buyers with properties where the property price is less than the buyer's maximum price. In summary, joins are powerful tools for data retrieval in SQL. They allow for complex data aggregation, with different types serving unique purposes. Using prefixes and aliases can make your queries clearer, and non-equijoins extend our querying capabilities beyond simple matches. Thanks for watching. If you enjoyed this video, please like, share, and subscribe for more content on data science and technology. See you next time.